Wait, can you solve this equation in just 10 seconds? Don't scroll away. I'm about to reveal a mathematical secret that 99% of students get wrong. By the end of this video, you'll be solving complex set notation problems faster than your calculator. Welcome back to MathVare, where we make math simple, one video at a time. I'm about to teach you the ultimate system for converting set builder notation to roster form. This is going to completely change how you approach set theory problems. Let's start with our first challenge. A equals the set of all x, where x squared minus 1 equals 0. Here's the key. We need to solve this equation step by step. First, we have x squared minus 1 equals 0. Now, here's where most students make their first mistake. They try to guess the answers instead of factoring systematically. Watch this. X squared minus 1 can be factored as x minus 1 times x plus 1 equals 0. This is a difference of squares pattern. Memorize this using the zero product property. Either x minus 1 equals 0 or x plus 1 equals 0. This gives us x equals 1 or x equals negative 1. Therefore, A equals the set containing negative 1 and 1. Notice how we list them in ascending order. That's the standard convention. Exercise B is tricky. B equals the set of all x, where x minus 1 squared equals 0. Here's the critical insight most students miss. When you have a perfect square equal to 0, there's only one solution. Taking the square root of both sides, the absolute value of x minus 1 equals 0. This means x minus 1 must equal 0. So x equals 1. Even though this is a quadratic equation, we get only one element in our set because it's a repeated root. So B equals the set containing just 1. Pro tip: whenever you see a perfect square equals 0, you're looking at a repeated root situation. Exercise C looks simple, but there's a hidden lesson. C equals the set of all x, where x plus 8 equals 9. This is a linear equation, the simplest type. Subtract 8 from both sides. X equals 1. Quick verification. 1 plus 8 does equal 9. Check. So C equals the set containing 1. Remember, even simple equations follow the same roster notation rules. Now for the boss level, D equals the set of all x where x cubed minus 2x squared plus x equals 2. This is a cubic equation, don't panic. Here's my systematic approach. Step 1, move everything to 1 side. X cubed minus 2x squared plus x minus 2 equals 0. Step 2, factor by grouping. Group the first two terms and the last two terms. X squared times x minus 2 plus 1 times x minus 2 equals 0. Step 3, factor out the common factor x minus 2. X squared plus 1 times x minus 2 equals 0. Now we solve. Each factor, x squared plus 1 equals 0, gives us x squared equals negative 1, since we need real numbers. This has no real solutions. But x minus 2 equals 0 gives us x equals 2. That's our answer. Therefore, D equals the set containing just 2. Now it's your turn. I'm leaving you with two challenge problems. Exercise E, the set of all x, our x plus 8 squared equals 9 squared. Exercise F, the set of all x, where x squared plus 16x squared equals 17 squared. Here are your hints. For E, take the square root of both sides carefully. Remember, you'll get positive and negative solutions. For F, factor out x first to simplify. Your work. Drop your answers in the comments below. I read every single one, and I'll heart the correct solutions. If this video just saved you hours of confusion, smash that like button. Subscribe to MathVare for more math mastery content, and don't forget to share this with any friends struggling with set theory. Next week, I'm revealing advanced set operations that will blow your mind. Hit that notification bell so you don't miss it. Remember, at MathVare, we're making math simple, one video at a time.